The Tonga eruption. Tonga is the location of the largest volcanic eruption ever observed from space. Are you prepared for a volatile subject? Hold on fast, as we are about to discuss the Tonga volcano eruption. On January 15, 2022, the Earth shook, the skies grew dark, and the world held its breath as the Tonga archipelago experienced the largest volcanic eruption ever observed from orbit. The eruption was so powerful that it could be heard from miles away, and the ash and debris it produced blanketed a large portion of the surrounding area, causing extensive harm to local ecosystems and posing a potential threat to human health. But have no fear, because we're here to delve deeply into the science, impacts, and response efforts surrounding this extraordinary natural occurrence. From the fascinating geology of the Tonga volcano to the heroic efforts of emergency responders and researchers, we will examine every facet of the Tonga volcano eruption and cast light on what it means for the planet and its inhabitants. Understanding the eruption. The Tonga volcano, also known as Tonga, is part of the Tonga Islands and is located in the South Pacific Ocean. It is a stratovolcano, which is a tall, conical volcano composed of numerous layers of solidified magma, volcanic ash, and other substances. On January 15, 2022, the Tonga volcano erupted, causing extensive damage to the nearby islands and generating a plume of ash and smog that rose more than 200,000 feet into the air. The eruption was so intense that NASA satellites were able to capture images of it from space. The eruption produced a plume of smoke and debris that covered an area greater than 11 million square kilometers, which is roughly the size of the United States. The eruption of the Tonga volcano was closely monitored by scientists and emergency responders from around the globe, who assessed the eruption's effects and coordinated response efforts. In the immediate aftermath of the eruption, ashfall and detritus from the eruption impacted local ecosystems and posed a potential risk to human health. Residents of the adjacent islands were advised to remain indoors and avoid contact with the ash and other hazardous materials. In the days and weeks following the eruption, a team of scientists and researchers assessed the damage and developed a recovery and restoration plan. This included conducting surveys of affected areas, monitoring air and water quality, and devising strategies for debris removal and habitat restoration. The scientific reasons behind the eruption. The eruption of the Tonga volcano was caused by the movement of tectonic plates beneath the surface of the Earth. The Tonga Islands are located at the boundary between the Pacific and Australian plates, two of the greatest tectonic plates on the surface of the Earth. The Pacific plate is approaching the Australian plate at approximately 4.5 centimeters per year. As the two plates migrate towards each other, the pressure between them increases, causing magma to rise to the surface of the Earth. This magma is less dense than the surrounding solid rock, so it rises through fissures and openings in the Earth's crust, eventually reaching the surface and causing an eruption. The Tonga volcano is a stratovolcano, which is a tall, conical volcano composed of numerous layers of hardened magma, volcanic ash, and other substances. Stratovolcanoes are typically associated with explosive eruptions, which are caused by an internal accumulation of pressure. During an explosive eruption, magma, along with ash, gas, and other substances, are discharged from the volcano. Frequently, magma is extremely viscous, meaning it is thick, sticky, and resistant to flow. This can cause magma to become confined within the volcano, leading to a pressure buildup that can make the eruption more violent. The eruption in Tonga was categorized as a Plinian eruption, the most explosive form of volcanic eruption. Large, vertical eruption columns that can reach tens of kilometers into the atmosphere distinguish Plinian eruptions. The release of gas and other materials from the magma causes these eruptions, which can result in the rapid ascent of a high-pressure column of debris and gas into the atmosphere. Pyroclastic flows are fast-moving, extremely hot currents of gas and volcanic material that can travel down the sides of a volcano at velocities of up to 700 kilometers per hour. These flows can be extremely destructive, causing substantial harm to buildings and other structures. Effects on the environment. Locally and globally, the Tonga volcano eruption had a significant impact on the environment. The eruption released a significant quantity of debris and sulfur dioxide into the atmosphere, which can have far-reaching environmental effects. Locally, the eruption had a significant impact on the Tonga Islands, as ash and lava flows devastated buildings and infrastructure and caused extensive environmental damage. The lava flows and pyroclastic flows obliterated vegetation and habitats, and the ashfall rendered the water sources unfit for consumption. The ash and sulfur dioxide that were released into the atmosphere can affect the climate and air quality on a global scale. The debris can cause respiratory issues and damage crops and other plant life. The sulfur dioxide can react with other compounds in the atmosphere to produce sulfuric acid, which can contribute to acid rain and has a climate cooling effect. In addition to the immediate environmental effects of the eruption, there are also long-term effects to consider. The eruption can alter the landscape and have lasting effects on the ecosystem. Ashes can provide a fertile substrate for new plant growth, but they can also suffocate existing vegetation and fauna. Intervention and recovery efforts. In the aftermath of the Tonga volcano eruption, response and recovery efforts have centered on providing immediate aid to affected communities, assuring the safety of residents, and minimizing environmental damage. Emergency personnel, including police and military personnel, have been dispatched to the affected areas to aid those in need. Evacuation centers have been established to provide displaced residents with shelter, food, and medical care, and efforts are underway to restore essential services such as electricity, water, and communications. Governments and international aid organizations have also provided assistance, including financial aid and supplies such as food, water, and medical equipment. For instance, the Australian government has provided Tonga with $10 million in aid to assist with the recovery effort. Monitoring the environment has also been a major focus of the response, with scientists and researchers assessing the impact of the eruption on the environment and developing long-term mitigation strategies. This includes monitoring water sources for contamination, evaluating the effect on wildlife and vegetation, and monitoring air quality for potential health hazards. As affected communities labor to rebuild and restore infrastructure, homes, and livelihoods, recovery efforts will continue. In addition to focusing on physical recovery, efforts will need to be made to support the mental health and well-being of those affected by the eruption, including addressing trauma and providing support for mourning and loss. Tonga is seen by satellite. Multiple satellites orbiting the Earth, including the National Oceanic and Atmospheric Administration, operated GO-17 weather satellite, observed the Tonga volcano eruption from space. From its vantage location in geostationary orbit, approximately 22,000 miles above the Earth's surface, the GO-17 satellite captured images of the eruption. The Advanced Baseline Imager (ABI) instrument on board the satellite captured visible and infrared imagery of the eruption as it transpired, offering a unique perspective on the event. In addition to the GO-17 satellite, other Earth observation satellites captured images of the Tonga volcano eruption from orbit, including the European Orbit Agency's Sentinel-3 and the Japan Aerospace Exploration Agency's ALOS-2. Having the ability to observe natural disasters and other significant events from space provides scientists and emergency responders with valuable data, allowing them to better comprehend the scope and impact of such events and to respond more effectively. The satellite images captured during the Tonga volcano eruption served to provide a global perspective on the event and aided in the subsequent monitoring and response efforts. Alright, we've covered a lot of terrain today, from the science of volcanic eruptions to the environmental and humanitarian consequences of the eruption in Tonga. However, before we conclude, let's take a moment to appreciate the immense power and grandeur of Mother Nature. The eruption in Tonga served as a reminder that despite our advanced technology and knowledge, we are still at the mercy of the forces that shape our planet. But let us also take solace in the fact that when calamity strikes, humanity demonstrates remarkable resilience and compassion. From the courageous emergency responders who risked their lives to assist those affected by the eruption to the researchers working assiduously to understand its long-term effects, we have witnessed a number of truly inspiring efforts in the aftermath of this event. Therefore, let's continue to learn, continue to explore, and continue to support one another as we navigate the wild and wonderful globe we call home. Who knows, maybe one day we'll observe another eruption as magnificent as the one we witnessed in Tonga. Stay curious and secure until then, and thank you for watching. Remember to like and subscribe to our channel for more fascinating astronomy and science videos.